Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we launch your brain with weird and wonderful science. I'm Ian Woolf. On this Martian edition, astrobiologist Bonnie Teece and Martin van Kranendonk and astrophysicist Kirsten talks about perseverance and the search for life on Mars. But first, here's news of other trips to Mars. A race to Mars? Every 2 years, Mars and Earth are a little closer together in their orbits than at any other time. These 3 weeks are when it's cheapest and fastest to send a spacecraft from Earth to Mars. The United Arab Emirates, China and the United States have all launched automated spacecraft to Mars within days of each other. The European Space Agency and Russia's Roscos planned to send their own spacecraft, but due to the pandemic, they've had to delay the launch until 2022. The United Arab Emirates launched its HOPE orbiter to Mars atop a Japanese rocket on July 19th. The orbiter will arrive to take up an equatorial orbit around Mars in February 2021 to commemorate the United Arab Emirates' 50th anniversary. HOPE's mission is to gather comprehensive data about the Martian atmosphere in all its complexity. The atmosphere of Mars has been very thin for a very long time and is now mostly carbon dioxide. However, a long time ago, it was once thick enough to keep the planet's water in place. The researchers hope to find out how weather on Mars changes over the course of a day and of a year at every spot on the red planet, and how Mars is losing its atmosphere. HOPE is equipped with an imager and 2 spectrometers. The probe will provide detailed images of the planet's surface while gathering data that lets its scientists track what ingredients are located where in the atmosphere of Mars. The Chinese government launched its Tianwen-1 probe on July 23rd on a Long March 5 rocket from Wenchang, China, sending to Mars an orbiter, lander and rover, also due to arrive in February 2021. The timing of Tianwen-1's landing on Mars commemorates the 50th anniversary of China's first satellite launch. Tianwen-1's mission is to study the composition of the Martian atmosphere, as well as contribute to the ongoing search for past and present life on the planet. The rover will land a few months after the orbiter reaches Mars. The solar-powered 6-wheeled rover was developed to operate for at least 3 months on the Martian surface. NASA launched Perseverance to Mars on July 30th. Perseverance will hunt for signs of habitable environments on Mars while searching for signs of past microbial life. The rover will also cache a series of soil samples that can be returned to Earth with a future mission. NASA PR insists that these 3 spacecraft hurtling into space at around the same time to arrive around the same time can't be a race because NASA has already been the first to send several successful missions to Mars. Perseverance's mission is planned to last for 687 days or 1 Martian year. Fusion is still only 15 years away. The ITER project started in 2005 as an international collaboration between 35 different nations to design and build a nuclear reactor based on the fusion of light atoms like the deuterium and tritium isotopes of hydrogen with lithium. By contrast, current nuclear power reactors rely on the fission of heavy atoms from elements like uranium and plutonium. Nuclear fusion is the process that powers the Sun and all the other stars. The process is so hot that you need to use magnetic force fields to hold the electrically charged gas plasma. Any physical container would just vaporize. If successful when it starts up in 2035, ITER will be the first fusion reactor to produce more energy than it consumes. ITER is designed to produce 500 megawatts of power for 50 megawatts input. Sadly, there's currently no plans to harness or store that power. In favour of fusion is that it produces more energy for less fuel than nuclear fission or fossil fuels. The waste from nuclear fusion is the power plant itself when it's decommissioned. The reactor and its parts are radioactively dangerous for just 100 years, instead of hundreds of thousands of years for fission waste. Against fusion is that it's very difficult, and the joke is that it's just been 10 years away for many decades. If you thought the Fukushima fission reactor had a problem when the power stopped cooling its nuclear waste, just wait until the first nuclear fusion reactor suffers a power failure with its magnetic confinement of superhot plasma. Compressed gases hotter than the sun released all at once in every direction. The worst thing about nuclear fusion as a power option for the world is that it relies on using lithium for fuel. All of the world's lithium reserves are bespoke for battery storage for cars and renewable energy generators, and there's none to spare. There isn't enough lithium on Earth to replace every petrol car with an electric car, despite that being the plan for many nations. Bolivia has already had a coup that happens to have allowed Elon Musk's Tesla company to get access to Bolivia's lithium reserves. Tritium is even rarer and is only found in fossil gas reserves. There's lots of deuterium in the ocean, but you need lithium or tritium to use it as a nuclear fusion fuel. Perhaps we could mine helium-3 from the moon and transmute it to tritium for our nuclear fusion reactors. Or perhaps we can find new chemistry to make the electric batteries we need for the zero carbon emissions future that is the only way we can survive. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. Is there life on Mars? On the 30th of July 2020, NASA launched the Perseverance rover on its journey to Mars to search for life. Bonnie Teece is a PhD candidate at the Australian Centre for Astrobiology at the University of New South Wales. Kirsten Banks is a PhD student at the University of New South Wales studying galactic archaeology. Martin van Kranendonk is the director of the Australian Centre for Astrobiology and a professor of geology at the University of New South Wales. I spoke to all three of them by Zoom and began by asking about the role of the Australian Centre for Astrobiology in the plans for NASA's Perseverance rover's search for life on Mars.
We've been in touch and involved with the Mars 2020 Perseverance program for about the last 3 or 4 years. And last year we had the entire team on the Mars 2020 rover mission come to Australia, to the northwest of the country for a field trip. And it was a workshop where they, and for some of them, many for the first time, could have a look at ancient life on Earth in rocks about 3.5 billion years old that are about the same age as the rocks that they're traveling to Mars to look for signs of life. So for many of them, it was the first time to get a real appreciation of what these signatures of life looked like in the field. And also think about the challenges of, even just the really practical components, not even just trying to figure out what kind of wriggly texture and crack was important or not important, but actually how would we drill and where would we sample for this specific texture and what's the best criteria. And so really for a week, we just pored over these really important outcrops, and everybody sort of saw it with their own eyes and tried to apply their science and their instruments on Mars to what they were looking at under their feet. So Yeah, it was a really rewarding trip for everyone, and Bonnie was involved in that, and we had a big team up there. It was great fun.
And the Pilbara sort of looks a little bit like Mars with all the red rocks and dirt.
It does indeed. It has a lot of components that are similar to Mars. Not so much the Mars we see today, and you're right, there's that look that everybody sort of equates between the two areas, but that's relatively superficial. On a much deeper level, the rocks up in the Pilbara are quite unique in the world because they're incredibly well preserved, but unbelievably old. 3.5 billion years is just a mind-boggling stretch of time. And it's about the same time that Mars was actually quite similar to Earth. It had rainfall, flowing rivers, it had volcanoes, and it had many of the ingredients of life that we know were important for starting life on Earth. And that's really Mars an exciting target because it has those kind of ingredients and maybe the Goldilocks environment of being not too far from the sun, not too close, but just having the right kind of ingredients that maybe life could have got started there. And so we're all about trying to understand, if you've got a whole planet to go and look, where would you go? What specific type of rock or environment would yield the best chance of success for finding perhaps extremely faint traces of life? We're not looking for dinosaurs here. We're looking for communities of microorganisms that leave behind tiny little signatures in the rock record that really need a specialist eye to eke out from the rocks. And so that's part of what our training workshop up at the Pilbara was all about last year.
Yeah, one thing that I thought was really striking that I hadn't considered in great detail before that field trip was how we're really looking for very small pockets, like these rocks that could be the areas of best preservation. If you take the rover and you turn right and you miss those fossils, well, then you miss them. So understanding the context of the rocks, understanding where that life is most likely to be is really, really important to actually looking for that life.
And the whole process of looking for life is pretty fraught. I mean, they've sent, was it a long time ago, in one of the very earliest rovers, they sent something to detect life, but it wasn't enough evidence. So how do you detect life?
So there have been a few detections which have made people question whether it could be a signal of life. Just a few years ago, the Curiosity rover detected some organic compounds, which started a conversation about whether these compounds were produced by biology or not. And it's most likely that they were not produced by biology, but were actually generated from a meteorite impact. So one of the key things when you're looking for life on other planets or in deep time is that you'd like to see multiple lines of evidence. You'd want to find chemical evidence, but also physical evidence and evidence in a lot of different ways to strengthen the argument that you found alien life.
That's a really good point because we've kind of been burned before. There was that huge expose in, I guess, the mid-90s about, finding life on a Martian that came to Earth. And they had a couple of lines of evidence that looked really strong, but really when people then analyzed it in great detail over decades, and they found that those, lines of evidence have actually fell away as we learned more about it. And science is all about continual learning. We get better at what we do, and we find new techniques and develop technologies that can assist in our understanding. But Bonnie's point is really, really appropriate because, you and I, we're chemical systems, but we're also alive systems. And one of the huge challenges in looking at signs of life 3.5 billion years ago is how can you discriminate between life and just chemistry? Because everything will leave a chemical system, but how can you definitively prove that it was only made by life and not by a meteorite strike or groundwater or some other kind of chemical reaction? And that's really, the forefront of our science is learning how to discriminate between those different possibilities. And so that aspect of sending the rovers up, you're right. The Viking mission back in the 70s found some chemical traces that are associated with life, but nothing definitive. And so, for example, now they're also finding these traces of methane on Mars. And methane is a gas that can produce by life. So when cows belch, they produce methane. So that's a signature of life. Well, you can also get methane through processes that don't involve life. So there's been lots of excitement and teasers, but nothing that is definitive yet. And now the bar for defining life, and especially ancient life, is unbelievably high. And it's really down to a few compounds that are specific to life, if you can find the organic molecules, or if you have something that's absolutely definitive in terms of a rock texture or something. But those are always controversial. So we're always trying to prod and find new ways to investigate. And so one of the key things about this Perseverance mission is collecting samples to bring back to Earth. Because even though we have an unbelievably sophisticated array of scientific tools launching to Mars on their way now that can probe and zing, we got a laser and we got elemental analyses, we got all sorts of things. But to prove life, those samples would have to come back to Earth, where we can apply the most sophisticated tests that use enormous instruments for analysis. And so that's really the next step in this interplanetary exploration, is to return samples back to Earth.
So I guess it just goes to show that finding life and being very sure about yourself is a very complex question to answer, and a very complex process of science as well. I'm not an astrobiologist, but I'm just enthralled by how much there needs to be done just to confirm or deny or be somewhere in the middle, which is okay, which is, like Martin said, that's what science is. We're continuously improving upon our way to research and improving on our way to get to these definitive or close to definitive results. And I'm really excited for what the new Mars rover Perseverance will possibly get for us.
And so what sort of sensors does it have?
So Perseverance has a payload of instruments, and some of them are dedicated to helping find evidence of past life or characterizing geology. And some others are for things like preparing for future human exploration. Some of the key instruments that would be really integral in establishing life would be something like Pixel, which was designed by an Australian scientist and her team. And Pixel is an elemental mapper, and it can map elements at a really, really fine scale and really understand the interactions between different elements. And it can show if there was signs of life, those interactions between certain elements. There's also an instrument called Sherlock, which is a UV Raman Spectrometer, which is a lot of words. And it is just something that can help pick up organic molecules on fine scale and give an idea about where those organics might lie. And so with different instruments, they have complementary information that you can use together to start building up that strong picture of evidence that we've just been talking about.
And another instrument that I really like on top of that is not just the instruments that are finding extra life, but there's also an instrument called MOXIE, which I really, really loved reading about when I first started reading about Percy. And it's the Mars Oxygen In Situ Resource Utilization Experiment. Again, lots of words. And MOXIE essentially is making oxygen from the Martian atmosphere, which I thought when I first read about it, oxygen for future astronauts to breathe when they go to Mars. But it's not just that. It's also to create liquid oxygen to provide fuel to potentially launch back off of the red planet when we're ready to come back home. And also, not to mention, there are 23 cameras on Percy, so plenty of opportunity for selfies.
But by far the best instrument, I think, or the most exciting instrument, is the SuperCam. That's one of the 23 cameras that Kirsten just mentioned, but it's a total sci-fi experiment. It sits right on the masthead, so looking forward, and it's a camera and a laser and an elemental analyzer at the same time. This thing is the best thing ever. I wish I had one in the field with me, but it can zap a laser about the size of the point of a pencil on a rock up to 7 meters away. And then it vaporizes a bit of the rock. And as that vapor is in the cloud, it has a spectrometer that can sense what the minerals are. And so it actually does this, far away analysis of rocks. And so it can just go up there and go zap, 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 zap. Oh, we'll take that one, not that one. And it's just the best thing.
That's so cool. I can just imagine Percy being like, pew, pew, find minerals. Let's go.
That's exactly what it's doing. And then all the other sophisticated machines that Bonnie and Kirsten talked about are really as follow-up. And as a geologist, that's really very much how we go about our science as well. We use our eyes in the first instance to go up to a rock and say, oh, that looks interesting. Then we get our hammer, we collect the sample, and we take it back to our laboratories where we do the laser analysis and the elemental spectrometry and all the rest of it. But the Perseverance rover has that capacity built in a vehicle about the size of an SUV or so, and it can just wheel around and do its analyses on the go. I wish I had one of those for my fieldwork. It would be amazing.
Bit of drive-by geology.
Drive-by geology for a mere $2 billion.
There was something online about it collecting samples of soil as well, and I didn't know what it was going to do with them once it sort of put them in little jars or something on the rover. Yeah,
so the idea with the current rover that's up there with Curiosity, they can drill and take samples of soil or of rock, and they can analyze it in the machine itself, in the rover itself, and they get a whole bunch of information about that. But in this case, what they decided to do was have a suite of instruments that would be able to identify the most exciting type of sample material on the ground, and then collect them, either the soil or the rock or the dirt, and put it in those little tubes and bring those back to Earth. So they won't do a lot of analysis on Mars, but they'll identify the best, most likely samples to collect. And they've decided on a whole suite of samples. So some will specifically look for life, and others will inform us about how Mars formed and evolved as a planet. And so that collection of samples, I think it's 21 or 27 or something like that, will then be put in a storage place all together and basically just left on the surface of Mars until they can send a second mission to come and pick those samples up, blast them back into orbit around Mars, and then in fact a third mission will have to come and pick up those samples from orbit and bring them back to our labs. And it just shows, that Mars is so far away and the technology is right at the limit of what we're capable of. In fact, mission 2 and mission 3 aren't even fully designed yet. So they're planning well ahead of where the technology is, kind of forecasting where we'll be in a decade's time to bring those samples back. So wait a while, it won't be until the very earliest 2031 before those samples can come back, and maybe later than then. But it's a great challenge. And the interesting thing is that's really inspired a new race well, it's not really a race, but there's a new rush of investigations for Mars. So, it's not just NASA that's launched, but the United Arab Emirates have launched a satellite. China has launched a rover that will land on Mars. And the European Space Agency, who were supposed to launch this year also, they've been delayed for a couple of years, but they're launching a rover themselves in a couple of years. So there's actually a lot of activity, and it sort of seems like Mars is the forefront that allows us to challenge ourselves and see what we can do. So it's a really exciting time to be involved.
So get out there, kids. You can get a job in Martian exploration.
That was part 1 of my discussion with Bonnie Teece, Kirsten Banks and Martin van Kranendonk about Perseverance's search for life on Mars. Listen next week for part 2. The video of the Zoom interview will go onto YouTube shortly afterwards. You can now see the video of my interviews with James Hayes about odour and Ian Bryce about masks on the Diffusion YouTube channel. That's youtube.com/c/Diffusion Radio. Subscribe. And that's all from us this week on Diffusion. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. The news music was Rhinos Theme by Kevin MacLeod of Incompetech.com. I produced this week's Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including 2RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2MVR in Nambucca Valley, 3MBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7LTN in Launceston, Tasmania, and 2XXFM in Canberra. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 1,000 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Join my patrons at patreon.com/diffusionradio. Make a donation through paypal.me/Ian Woolf. Support Diffusion by buying from the affiliate links at diffusionradio.com/support. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.